Okay, so maybe I'll look at two examples where we want to find the inverse of a function, or at least determine if it exists. For example, let's say I'm given a formula like this. Okay, and I want to know, is there an inverse function for that? Okay, so of course, like I was telling you, you could potentially graph this function, and then if it's one-to-one, you'll know there's an inverse, but that's kind of hard to graph. So actually, to answer the question, if we can solve for x this equation, we know it's one-to-one, and as a bonus, we're going to get what the inverse function is. So we're going to just solve for x, or if you prefer, we could actually use the solution where we get the formula for the inverse in terms of x by initially interchanging the roles of x and y. Okay, so maybe here I'll start by interchange the roles of x and y. So I'll write x is 5y plus 1 over x minus 1, and then now instead of solving for x, of course, I'm solving for y, and solve for y. So so how do I solve for y here? I feel like I made a mistake somewhere. Yeah, this is x. This is x. This is no, everything's y on the other side. Okay, sorry. 5y plus 1 over y minus 1. Okay, now I want to solve for y. So that's equivalent to solving for x above, of course. So now I multiply on both sides by y minus 1. You distribute. Because my goal is to have like all the terms including y together. I multiply by y minus 1 because I didn't want to work with fractions. So you see these two terms here, I'm going to put them together, and they have a common factor of y, so I'll be able to factor y out of them. So I'm going to keep on one side everything that has y in it, and send everything that has, well, that does not involve y on the other side. Then factor y here, because eventually I want to solve for that. And finally, I divide by x minus 5. Okay, and I get y as a function of x. So this is my inverse function. So it shows it's possible to solve the initial equation for x. Okay, and f inverse of x is x plus 1 over x minus 5. So I know some of you have trouble doing those steps. So what I recommend, hide this now, okay? Start again with the problem and see if you can redo those steps, okay, and understand the logic behind it, okay? Second example, okay? So given the graph of the square root function, okay, I want you to graph its inverse and find a formula for the inverse. Okay, go ahead, try it. At least find the graph. Then you can look what I do for finding a formula for the inverse, or maybe you can try that on your own. I don't know. So we're going to graph the inverse. Okay. So if I know that for graphing the inverse, I'm going to need to reflect about the line y equals x. Okay. I'm going to have to be kind of precise here. So okay, maybe 1, 2, 3, 4. And here 1, 2. Okay, so 0, 0, root of f of 0 is 0, f of 1 is root of 1, which is 1, so we're right on the line actually. F of 4 is 2, so we're here. So remember, the graph looks like this for the square root function. Okay, it's slightly above the line y equals x until you reach x equals 1. So this is 1, 1. And after that, it's below the graph. Now, if we want to reflect that, well, we can actually start by reflecting the points we have. So 0, 0 reflected. Well, it's already on the line y equals x. 1, 1 also already on the line y equals x. We just need to reflect the third one. So we're going to end up 2, 4. If you flip those around, you get 4, 2. No, actually, it's my bad. This is 4, 2. So if you flip those around, you get 2, 4. So 2, 4, we're up here. So if I join those with... So of course now let's just reflect. So this part that I reflect is now it's going to be below the line y equals x. And then it goes up like that. So this is the graph of the inverse. Okay. Now let's try to find a formula. To find a formula, I've got to work with the equation. Okay, so I know that y is root of x. So to find the inverse, what do I need to do? Okay, I need to interchange the role of x and y and try to solve for y. Now to solve for y, I'm going to need to square both sides, right? So if I square both sides, now the square of a... So you have to be careful here. If I do the square root of something squared, that's actually the absolute value. But if you do this, if you square the square root, you're going to get what's underneath the square root. Okay, for sure. So this is correct. Now this is really x. So square root of y squared, that's really y. Okay, and that gives us, actually let's rewrite it like that. Okay, that's our inverse function. So in other words, we can write f inverse of x is x squared. You're like, hey, wait a second. X squared, I know what this graph looks like. Actually, there's another part missing here. So why don't we have that part? We just have like one branch of x squared. We don't have all of x squared, okay? So of course, you have to remind yourself that the range of the initial function is going to become the domain of the inverse. So let's take a look again at our domain and range for our square root function. So this is f, which is the square root function. So its domain is anything between 0 and infinity, because you can't take the square root of a negative. Okay? So its range now is what? Well, actually, we see it. It's going to be also anything from 0 to infinity. So that means that our inverse function, okay, is its domain now is the image of the, or the range of the initial function. So we actually restrict the values of x to 0 to infinity. So this is part, so this, what I frame here is part of the story. So if you want to be thorough here, this is if x is actually greater than or equal to 0, or x part of the interval 0 infinity. Okay, so in order to get the inverse of f, we have to actually restrict the function x squared, okay, to only positive values, and then we've got an inverse. So we're going to finish off. I'm going to give you a problem. You try it. Okay. The function is 1 over x plus 3. And try to sketch the graph of f, the inverse, and find a formula for the inverse. Okay. So I'm going to pause the video, and after that I will just show up the entire solution. I won't go through it with you. You're going to see the entire solution. You're going to be able to compare with what you have. Here we go. So you should have found f inverse is 1 over x minus 3. Kind of interesting, this problem. I just created it without really thinking. But the original function here, its graph is basically the graph of 1 over x shifted 3 units up because of the plus 3. Right? So if you start with the graph of 1 over x, okay, 1 over x plus 3 will shift this 3 units up. So that's why the asymptote, which was the x-axis, now becomes y equals 3. So this is an asymptote for the curve in blue. Okay, so this is the graph of 1 over x shifted 3 units up. And when you find the formula for the inverse, you actually realize, oh, 1 over x minus 3, that's basically taking 1 over x and replacing x with x minus 3. Therefore, okay, it's kind of like replacing x with x minus h. Okay. In other words, if you've got, let's call it g of x equals 1 over h, the function we have here is g of x minus 3. And we know that this is going to shift the graph 3 units to the right. And this is what happens here. If you look at the graph in green, it's the graph of 1 over x shifted 3 units to the right. Now there was an asymptote which was the y-axis, and now it's becoming y equals 3. See it here. Y equals 3 is the new asymptote. So here this is the graph of 1 over x shifted 3 units to the right. It's pretty cool to sort of connect it like that as well. But I got them initially. I got the graphs by just reflecting across the line of y equals x. And it's just later on I realized, oh, they're actually connected this way as well. Pretty cool.